practical session. I hope you can hear us. We had some technical difficulties because someone changed our whole setup around.
It's a bit spooky out here, I must admit.
Yeah, but I think you will see more in the lecture of all the spooky stuff David prepared.
That is just a glimpse in the future for the real Halloween evening today. This also works still perfectly. Okay. Nevertheless, we have to do some stuff today. Yeah?
And if you can't read the text, please tell us because we had some bitrate warning. So I hope it's sharp enough so you can read everything.
Functions is the topic of today. As always, we start with organizational matters. Then a very brief introduction to Valgrind. You will see then what we mean with Valgrind. Last time we discussed a lot about Structs, and we thought in the very end that there were something which is not completely clear. So we'll talk a bit more about Structs, and then the largest topic for today are the functions.
Yes, and with a big example on how to structure your code.
Yeah, so also in the direction of assignment 1. But the best news are now on the first slide of the organizational matters.
Yes, so next week, the next practical session will be in person now. So in P1, same time, and there won't be any live stream now. Also not on Tube, but the recording will be on Tube and on YouTube, right?
Yeah, it will be on Tube as well, but also on YouTube. So
yeah, so probably the next day, the recording will be on YouTube.
Yeah. This is great news. We're really looking forward to see you then in the lecture hall and not just present everything in front of a camera. So
yeah, so maybe we're even more spooky in person.
Which building? It's in the Campus Neue Technik, new campus in the Petersgasse 16. Not sure about this.
Yeah.
Just look it up, the largest lecture hall on TU Graz. Yeah, weekly exercises. So 10 exercises are released currently. These are all the exercises for assignment 1. And today there will be 3 more exercises released. However, you will find the tag A2 on these exercises on online GDB, and this means that they are not related to assignment 1 anymore, but they already are related to assignment 2. And you need to complete these exercises for assignment 2 do not obtain a point deduction on A2. Yeah, and always available at the same time. You know this already.
Yeah, I see a question. So when I try to open a weekly exercise, it says classroom not found or you haven't joined this class. There's a separate link in the Notion, which is the invite link, which is the longer one. You need to click this and then you can join the classroom, and then you will see it always when you're logged in.
Yeah, next slide, I think. Personal question hours. Next Tuesday will be again the next session of the personal question hours. We skipped the last hour, so it's from 4 to 6 now because we only have like 2 registrations per week. But
yeah,
this is a possibility to ask questions, so you can use it and you should use it. So maybe just as a reminder.
Yes, and because we know that there will be many students who have questions, especially right before the deadline of assignment 1, we'll hold a question hour next Monday. Next Monday, where all of you can join, ask questions, and we'll answer all of those. And also you can get personal help. So if you have problems specifically with your code, we can also help you. And
starting from 6 in the evening, open-ended, so as long as there are questions, and it's in the lecture hall in Infeldgasse, lecture hall I9, so it's next to the Lehrsaal EX that you probably have seen already, or the Hörsaal E8, both were the coding sessions. So if you went to a coding session, you know where this is.
And Yeah, mostly you can Google all of those buildings, just TU Graz and then this building, and you will find where this is.
Yeah, exactly.
Okay, then we can start with our first topic.
Just the question in the chat, you do not have to tag your submission, just the
last
commit.
Last commit.
Okay, a brief introduction to Valgrind. Why is this important now? Probably some of you have seen on the test report of your assignment 1 that there is some Valgrind log, and maybe you have seen also these categories, memory errors and memory leaks. This is a very large topic, and it will become more and more important over the next weeks when we come to the topics regarding arrays, pointers, dynamic memory. For now, we want to keep it very simple because there's just one case where memory errors can occur. And yeah, what does Valgrind for us? Valgrind is then a tool that does checks and checks whether there are memory errors or not.
So it's basically a bit like a debugger, just that you don't set these breakpoints, and it just gives you a summary at the end what went wrong.
Yeah. For assignment 1, there is exactly one type of error that can occur, and we talked about it last time, uninitialized variables. So if you have uninitialized variables, Valgrind would find out that there are uninitialized variables and can warn you, and you will get then memory errors.
So just if you access uninitialized variables.
So if you use them unintentionally. How to use Valgrind? You need to compile with the -g flag, same as with the debugger, and then you execute your program with Valgrind by just writing Valgrind in front of your compiled program. So last time we had this example here. We had the code where we have this integer a, and where we print the value of a, but we do not initialize a. And now I want to demonstrate you that Valgrind would find this error and would indicate this as a memory error. So I just copy the code now and paste it here. Then we open a new terminal, and we need to compile it. Can you do it? It's your keyboard there. So compilation as usual with the -g flag at the very end. So this works, and then we just write Valgrind, and then we write the executable, so not the code file, but really the file where the machine code is contained. And if we run this now, we can see in the very bottom line there is the error summary, and we have 5 errors. And now maybe this is a bit hard to read now, but it's a good thing to always start reading at the very beginning of this log. So here we executed the command that was created, and then we have here at the first point more or less is conditional jump or move depends on uninitialized values. So this is already the indicator we have uninitialized values. And then we see this happens in the main function in line 6 with the printf. And basically it's now your job that you see here, okay, in the printf this happens, what could be uninitialized? Okay, this can't be uninitialized. So the letter must be uninitialized. So the A is uninitialized. Okay, and that's the way how you find it out.
So the reason why we have many errors here is just because printf internally probably uses our variable more than once and then accesses it multiple times. Maybe should we try and fix it?
Yeah,
so we'll see how Valgrind, how it looks like if we initialize it and then execute it again with Valgrind. We can now see, okay, 0 errors from 0 context, and it's also way shorter, and now we know that our program didn't have any memory leaks, at least in the way we executed it.
Yeah, this is maybe then interesting to know at the moment if you have these memory errors and you wonder how to fix them. Now you have some idea here.
So if you have some memory errors for A1, they're probably just those uninitialized variables, and you can find them like we just saw by checking out these line numbers Valgrind gives you.
Of course, if you use more advanced concepts than we have presented here for assignment 1, and there could be other memory errors as well, and you should fix them. But probably then you already know about this and you can fix them on your own. Okay.
Then I think we can continue.
Yes.
And maybe something already related to the question in the chat, because now I want to talk, okay, now it is a bit later, more on structs first. I just have some few, sorry, I read the question that is this checked on make test? Yes. So in your test report, you see your memory errors.
Yeah, exactly. Yeah, they're marked there.
So now I just have some questions for you. You can answer them in the chat. We later also have a Slido quiz. But right now, let's stick to those questions. Namely, I want to demonstrate really what's the difference between a struct, which is a data type, and a variable, because there was some confusion. So in here, if you look at this code, again from the last time, same example, we have this x and this y point, this struct. And now we have this small point. So here I create this here. So what is the difference between point with a small p and a big P? And I think, yeah, one is a variable and one is a struct. Yeah, so I mean, it's quite easy to see this. Okay, point is a struct and here is a variable. But yeah, let's continue to the next one. So now the interesting thing is, what would we need to do if we want to create multiple of these points? So
yeah, basically, do we need to declare more structs? So if you go back to the previous slide, I think. So we need to,
if you want multiple points.
Okay, so we need to create a type of struct point 1, point 2, point 3, or
do we need to do something else? So I just want one point, I know, which is 0, 0, and a second point, which is this 1, 2.
Okay, an array is an option, but let's keep it without arrays at the very moment. And so we just, do we have to declare always a new struct, or do we just have to create new variables of the same struct?
I mean, the array was kind of in the right direction. Yeah. Yeah, so we can just create a new variable. Where, like this. Yeah, exactly.
Okay, yeah. Yeah, so yeah. The answers are really correct here now.
So let's look at this. And yes, this is the point of structs. We can create this data type once and then have multiple variables which all basically follow this format, which have an x and an y. And so basically this A has an x and also this B has an x. So they all have the same format as these points, and we can create as many points as we want just by this with this struct definition. So this is really just a data type like integer. Of course, if we want to create multiple integers, we can just create multiple variables with the data type integers. And here we can just create multiple variables with the data type point.
Yeah.
Yeah.
So this is really crucial that you do not need to declare multiple structs here outside. This has nothing to do with the actual variables that we create. This is just the building plan, what this variable should look like. But then the actual variable with concrete values is just down here and it just takes this as a building plan, but it's not further related.
Yeah, I also saw this in the chat. So a struct can also be seen as a template for a data type, more or less, or a template for a variable. So all these variables have an x, consist of 2 integers. Okay. Then I have one more question. Now we have this point with the big P, which is the struct, and this point here in lowercase letters, which is the variable. Maybe if you can remember from last lecture, if you want to create a function, which one would be correct? So A, where we use this point, or B, where we use this point?
We have a B which was deleted in the chat. We have an A, and we have another A. We have a few B's, a few A's again.
Okay. I think most of you are for A, and this is also, yeah, this is correct. Of course, here, this is the return type, and here we specify which types our parameters have. So we need a type here, and this lowercase point is not a type, this is our variable. So we could call my function now like this, but the type of this point is the point with the uppercase letter at the beginning.
Yeah.
Yeah.
Yeah. Do you have one more question regarding?
No.
Okay, because I have one. Somebody wrote this in the chat. If you want to have different structs here, different building plans, then you can do this, of course.
Yes.
You could, for example, I don't know, copy it. Maybe we add
Something
you
like
add
this.
the exact same idea. Yeah, so we have now a 3-dimensional point. And so we have now the 3-dimensional building plan for a point and a 2-dimensional one. But it would not make any sense to create 2 points with integer x and y as members, which are the same, because we can always create the variables and multiple variables of the same struct, of the same building plan. Yeah, this is also possible here.
Okay, then let's continue with the actual quiz.
Yeah.
The last few questions were just aimed at maybe just really hitting the right spot with where some confusion may lie and to clear that up. But now we have some Slido quiz about what you learned last time in the lecture. So
yeah, you can join it, hopefully, if this works. Yeah. So let's I have to look this up. We have around 107 viewers today. So we maybe wait a bit. Maybe you can already tell us in what direction the quiz will be. What is the topic about the quiz today?
So I said last lecture, the topic is about the last lecture, and I think the main topic from last lecture was functions.
Okay,
so we'll talk about functions in this quiz.
So I was not attentive enough to get this point. Okay.
I hope you paid attention in the lecture, because then you might be able to answer some questions.
Do we see how many?
Here, 41.
41. Maybe we wait for 50, but we don't want to lose too much time. Maybe also 50 viewers are just sitting in front of their PC and not listening to us. This is also okay. 2 more.
Okay, so let's start with the first question. Yeah, so what is the difference between a definition and a declaration of a function? Yeah, this was touched on in last lectures, and the possible answers are: the declaration has a body, the definition has a body, or both are the same, so there's no difference.
Say again when 50 have answered, because there's some delay, but I probably, we can answer it now.
Yeah.
The right answer is
How do I do this?
Okay, okay, in the meantime, while Julia tries to fix the quiz, I will tell you the right answer. The right answer is that the definition has a function body. Just remember.
No, I stopped the whole quiz.
Okay, so the definition of a function contains the function body, so it really implements what the function is doing. Yeah, so 82% of you answered correctly.
But they could change the vote after you revealed the correct answer.
Oh, okay. Yeah, but nevertheless. And the declaration of a function body is just writing what the function does. So what parameter it takes, what is the return value without writing the function body. And you need this in order to access functions. But the function, the definition really includes the whole definition of the function. So it tells the function what it should do.
Mm-hmm. Okay, then let's continue with the next question.
So without problems now.
So now, which of the following statements is true? Either a function has only one parameter type, or a function has only one return type, or both, or none.
Mm-hmm.
Okay, I see that most of you are voting for the same answer.
Okay, yeah, we have again around 50 votes, so we can now reveal the answers.
Lock, and now reveal.
Yeah, so the function really has one return type, and this is because we can only return one thing from the function. Very nice that nobody answered the function has only one parameter type, because the function can take arbitrary many parameters of arbitrary many types. And yeah, the other answers, of course, are not true in this case as well.
Let's continue with the next one. What is the difference between the scope and the lifetime of a variable? This might be a bit more trickier. And the answers are either scope and lifetime both refer to the time a variable is stored in memory, or scope describes the variable's memory location, lifetime describes its access permissions, or scope is where a variable can be accessed and lifetime is how long it exists in memory.
That is the most difficult question for today.
I saw some question in the chat about what about passing structs to functions and returning them from functions, and we'll see that today. Yes, we'll do that today.
50 people answered, so yeah, the right answer is scope is where a variable can be accessed. Yeah, so it determines when can you write the name of the variable in the code, and it works basically in a sloppy way. And the lifetime is when the variable lives, yeah, when the variable exists in the memory, and this can be longer than the scope. Yeah.
Then ready for the leaderboard?
Yes.
Okay, then yeah, congratulations, Dusan.
Very nice. Thank you for participating. And
yeah, I think it's also ranked by how long you take to answer, so that's nice. Even though, yeah, the first question didn't went that well, but yeah.
Okay, then we have a lot of things to do, so we need to continue.
Yes. Namely, functions.
Yeah, it's your part.
And we'll start with scope of variables with functions. And I'll just start coding. I'll first tell you what I want to do. Namely, so I have these two variables, so int b and int a. Let's say I have it like that. And now I want to swap those. So I want a to have the value 10 and b to have the value 5. So, okay, yeah, I could do this. I could do like a equals b. Then okay, no, this won't work. I need to store the value of a somewhere. and then something like this.
No, I do need the temp value, of course, in the end.
Yeah, I need the temp value.
Yeah, but very simple, right?
Yeah. So the A equals B afterwards, so A is 10, and B equals temp, and temp was the value which A had before we swapped it. We can't do something like this because A would equal to B, and then if we do it like this, both would have the same value. Okay, but I want to write a function for this. So something like I want swap, and then I want to pass the first and second variable, and I want those to be switched now somehow. I don't know, seems easy enough. Let's write such a function, swap. Let's call those parameters something different, like this. Okay, we take two integers, this is what we passed on here. And now I'll create this temporary variable, just like I did it in the main before, like this. And okay, now they should be swapped, right?
Yeah, so maybe we can print this in the very end.
No, again, something like I think I hit the wrong key, yes. Something like this.
Okay, so you print them, yeah, then it should be 10 and 5, and yeah, just run it, then we are done with this part and can continue with the next one.
Okay, so nothing changed.
Hey,
And I already saw in the chat no return, so it will not be affected in the main. And this is exactly what happens. Because these are different variables here, but maybe I'll draw this for you so you can follow this. So maybe a visual explanation is easier. Can you open the code? Yes.
Ha.
So we have this main here, and that I'm just drawing both variables. So we have this A, which is equal to 5, and B, which is equal to 10. So this here is basically the memory in our computer. Okay, then we have this main here, and at line 14 we are calling the swap function. So maybe something like this. Swap. Okay, what happens now in this swap? Well, we have this integer x and this integer y here. So we have a variable x and a variable I and a variable temp. But the crucial thing now is that here, when we are calling this function, these values are copied to this function. And maybe now you can already see why this goes wrong, because if I have this 5 here and this 10 here in this swap function, these are different variables. So they have no connection. Well, okay, maybe it still works. Let's just try it out. Line 5, temp equals x. So temp is 5.
I'm your debugger now. You can draw. I'm your debugger.
Yes. Then line 6, x equals y. So x now gets the value 10. And now line 7, y equals temp. So y now gets value 5. And now we return back to the main. But what happens now if we're not returning anything? Well, what happens is that the memory we have in this function just more or less is destroyed, and we're back in the main and nothing changed.
Okay, so in A and B, we didn't touch these variables, right?
Yeah.
And that's why they keep being the same.
Yes, so we had different variables. Most crucially, A and B were copied to swap, and we changed the copies, but these copies were deleted when we return. So this won't work. But maybe let's try something different. We have just the exact same code here. We had my explanation. How could we return multiple values? Because we said if we want to keep something from a function, we need to return it. And we have two values which we want to swap. So we would need to return multiple values.
But maybe if we go to the code, we could say something like, okay, swap, we return an integer.
But now which one?
Yeah, which to return and
because we need both.
Yeah.
And we just said in the quiz before that the function has one return type.
So I cannot do something like, I don't know, integer and integer.
Yeah.
This is not possible in C. In other languages it might be possible, but not in C.
So what do we do? Well, we also talked about something different, structs.
Yeah, Pavi, congrats.
Yes. Because we said with a struct, you can group multiple data types into one. And now we'll do exactly that. Yes. So I'll create a struct. And I want this struct just to store two ints. Yeah, okay, VS Code did already something for me. And I'll call this the first integer, the second integer, and what is this when storing two numbers? Well, we have a tuple.
Okay, I just want to go to the chat very briefly because other options are use an array. This is true, but we will not show this today, but you will see this in today's lecture. And global variables are not allowed in our course.
Yes.
But except for that, it would be an option, but they are not allowed in our course.
And many are already talking about pointers, but we haven't seen those yet. So I think you might see them sometime later in the course. Okay. So, well, now we have this variable, this tuple, which just holds these two integers. And now we can change our swap function to use a tuple. So we can return two numbers, but now as you already have this data type, we can also just receive this tuple to have both of these values here. And now this is basically the same.
So
we store the first in some temporary variable.
So the x becomes more or less first and y becomes second. Yeah.
Then we can override the first, the first integer because we already stored it somewhere. And then we can assign the second integer this value in the first one. And now the crucial difference, we can return our struct again. Because remember, this struct here, the struct we have here is copied to swap, and in order so that it's not destroyed at the end of the swap function, we return it back so we can still access those values.
How do we need to modify the main function now?
Okay, now we also need to store these two variables in a tuple, and as we have seen last times, we can use this initializer list to just assign the first one to A and the second one to B. We could also say, like this, as we've seen last time. But let's just remain like this because I think in a tuple, you can see this quite well. Okay, and now we pass this tuple to swap, but I think it might still not work because swap returns now this tuple with the swapped values, and we of course need to swap this. So maybe like this, call it swapped. And then we print the first and the second again. Yeah, so let's try it out. And now it worked. But maybe this A equals and B equals is now.
Seems a bit odd because A and B are not changed.
maybe let's do it like this. But now, yes, we had this tuple original, where we have still the original, and then the second swapped one. Maybe we can print both, and we can see, okay, in the original the values were untouched, and in the swapped one we exchanged them. Okay, and maybe just to come to also see this, like how I drew it earlier. Here, now this is the main. I represented this struct like this. So here is the name, we call it original, and this here is the tuple struct with 5 and 10.
Should I be your debugger again?
Yes.
So you can focus on drawing.
So the first thing is that we're calling the swap function. So I'll do it like before, like this. And we pass this original tuple to the swap function. And to do this, well, it is just copied to the swap function, and it's named it values, like this. What happens here now is that we also have a second variable temp, and we assign values.first to it, which is 5. Values.first up here becomes now values.second, 10, and values.second now becomes this temp variable, which is 5, and now we return values. So what happens now is when this now returns the swap function, not everything is deleted, but our struct is passed back. I didn't get all of it. Our struct is passed back to the main function down here, and we call it swapped. And now we have these two structs, the original one, the swapped one, and yeah, we can see that the values are swapped.
Very nice. So one hint at this point, as you can see, maybe drawing the variables, assigning values to it might help you, because then it's very easy to see what happens in your code. And the second thing, nice approach to swap two variables, but still A and B have the old values.
Yeah.
And this is extremely long, and you have to do this struct, and now you have this original struct and the swap struct. Is this the best thing that we can get, or
no? We'll see something better later in the course, maybe today.
Yeah, maybe.
But I don't want to spoil anything.
Okay, but this is really now, with the methods that we have, this is the best thing that we can get.
Yeah.
But
I can propose something even better.
Okay.
Maybe, okay, this is now something small where you can save some time. You don't need to create this original tuple up here. There's one thing you can do in C, namely directly in place, you can do something like this, where you just, like up here with this initializer list, and then just specify it like that, and then cast it to some data type. So in my case, to this tuple here, and then I won't need this. Yeah, but
okay,
now
so save one line with that.
Yeah, now it's a bit cleaner. So you don't need to create this extra variable here. You can just directly use this initializer list when calling this function, or anywhere else you need a tuple just once. So this is a nice trick, but even with this trick, this is quite cumbersome.
Yeah. We have two more questions in the chat. So can we loop through a struct somehow? This is not possible. We can only loop through arrays. Not in C, yeah? And one did not get the point of the temporary variable. Maybe you can draw it just very briefly what would happen. So let's assume what you did to the very beginning.
Let's go back to the original one.
Yeah, I just write it without but maybe
just do it in the main with this main.
You need to write. Maybe say A equals B and B equals A.
I think if you want to swap without this temporary variable, well, you would do something like this, right? You think, okay, now both values are swapped. But let's look at it in memory. So we have these first two lines, which assigns 5 to A and 10 to B. Okay. Then we get to line 23, and now we set A to B. So what happens here is that the value of B is put into A, like this. And maybe you can already see a problem because we just lost the original value of 5. And if we then do, okay, B is equal to A, well, okay, we take the value of A and put it into B. Now both are 10.
Yeah, so this doesn't work.
So we need this temporary variable to store the original value of A, or else we'll lose it.
Okay, this nice explanation was well enough. If you leave out the original struct below with this new solution, how would the printf have to be adjusted?
Then you can't print those values because you just have them up here.
Yeah. Then they would not be a variable that you can use in the main function.
So because if you don't have this original, we also can't print it and if you want to print this, then probably the better approach is to use the original.
Yeah.
Okay.
I think, it looks nice. Do you have anything more on the slides, or are you done?
I think I'm done.
Okay,
I just have, as always, afterwards you can look at the code in the slides.
Okay, then we come to even more programming now. We have one more question here, maybe. If you just call a function without assigning it, where does the return value go then? So if we do something like, we take the swap and this is removed. What happens with the return value?
Well, we just lose it. It goes basically nowhere. It just vanishes. We don't have access to it.
So as an example, the printf function would always return something, whether printf was successful or not. And we do not talk about it because it's not important for our course, and we just implicitly lose this return value without checking it. So you already did this at some point in the course. Keyboard layout switch. Worked. Very nice. Okay. Any more questions we have?
I don't think so.
Okay. Then let me just adjust a bit my mouse because it's a bit awkward. And I ruined everything now. Okay. Live coding. We now want to do a bigger example, because in assignment 1 you need to program something larger. Now we have just seen one function, and we have seen in the last practicals code consisting of 20 lines at most. And now we want to do something larger. Let's see how far we get today. And just look at the task that we have. And remember, if you have been to the practicals last time, we printed the binary representation of a number. And now we want to make this program a bit larger. So today we want to first read a number from the user, then print the binary representation with the code that we already have. And then this whole process should be repeated. Yeah, so we can always answer the number, and sometimes the program stops, but we can do this repeatedly. Now, this is not just a single thing that we want to do, but it's really multiple things that our program should do. So it's already a bit more complex. And now it's really crucial that we split it into functions such that every part of the program, stays small. And that's otherwise, if you have really large functions, if you really have large things that happen in your code, it's probably harder that you know what you're doing in the code, that if you look at it later, that you can again know what the code is doing. So we want to see this. So last time this was our code, so I just copy it and very briefly explain it again. If I can copy it. No, I can't copy it.
Just Control A.
Now it works. Okay, go to the main function. This is what we had last time. So we had a fixed integer number, for example 42. We had some weird bit mask that I explained last time, and then we iterated over all the bits of this integer. I think last time we did it with a character with 8 bits on it. Today I just implemented it with 32 bits, but it's the same thing. And we did some weird calculation that gets the bit, and if the bit is active, then we print the 1. If the bit is not active, we print the 0. And I also additionally introduced something that makes the printing better. So after every 4th bit, I print an additional space, and after every 8 bit, also print this bar here just for some separation, the pipe for some separation. And just we can run this program maybe. So we have this here with gang and with main. So we get now the binary representation of the number 42, which is very uninteresting at the beginning, and here in the very end some bits are set to 1. 32 plus 8 is 40 plus 2 is 42. So this is the correct representation. Okay, now for today we said that we want to do a bit more. So let me maybe write this here as a comment. So we want to read a number from the user, then print the binary representation, and then repeat the whole process. For the first part, I would say we skip this last thing, repeat the whole process, and we focus on reading in a number from the user and print the binary representation. Now, of course, I could say, very nice, we have here the code, and we just read in the number now at the very beginning in the main function, and then do all the other stuff, but it's a bit unstructured, I would say. So I want to start reading a number from the user using a function. Okay, the question is now, a function has parameters and it has a return value. Now the question is, what do we need as parameters? What should be the return value? Parameters are probably not needed because this does not depend on anything. We just read a number from the user. So we do not have any parameters, but we want to obtain something from this function. We want to obtain the user input. So it needs to have a return value. So this function that reads the input of the user must be of the type, it returns something, then it has some name, and it has no parameters, so we explicitly write void here. And now what would be a nice name for this function? Do you have any suggestion?
Read user input or read integer?
Read integer, for example. Read integer. So it takes no parameters, it returns an integer. And now the goal is that I read the number from the user. So I copy this up here and write unsigned integer number is read integer. Okay, now I see one mistake I did. I want to store it in an unsigned integer, so I probably should not return an integer, but also an unsigned integer. So integer which only takes non-negative values. And with that thing, yeah, I just need to write the read integer function now, but my main function did not get longer. So it's clear now, if you read this line, something is read from the user, but it's not then coded in the main function. And this makes it really easy to read the main function at the very end. But now we have to implement this function. So we had the question up about this. What was this thing here? Function declaration or definition?
This was a declaration.
So we need to do the definition now. And we usually do this at the very end. Okay. So we read in the integer, maybe enter a positive integer. We do it like this. Then we call scanf. So this is also enough for assignment 1. And we need to use now u, the flag u, because unsigned. Yeah, u unsigned. We store it in we don't have a variable yet, so we need to create a variable. Unsigned integer. I'll call it input. Maybe initialize it to 0 because we said initializing is always good. Write input here, and then at the very end we return the input. So this is now the code that reads an integer from the user with some message here. We get the input, we return the input. This variable, as we said, is then copied. So the value of the variable is then copied into the number here. And the remaining part is then just executed here in the main function. So the user input should already work. So maybe I try it and then we see whether there are questions in the chat. So if I compile it, run main, now I really get ask enter positive integer. I don't know. Maybe this, the date of today, and then we get some binary representation of the integer. Okay. Are there any questions in the chat so far? Have you seen something?
Aren't we risking an underflow if a negative number is entered? And yes, if you enter a negative number, you will get an underflow because we are only storing it in an unsigned integer.
Yeah. So so we do not focus now on that the input is really valid, but we assume that the input is valid for now, because dealing with inputs in C and verifying that they're correct, this is a hard task. Okay. Now we have this read integer thing, very pretty. Now this large thing here, this prints the binary representation in the main function. And this is really long. Yeah, we zoom out a bit. You see this is like whole page now. And maybe this is not so related to the main function. So maybe we can write a function that prints the binary representation of the number. So I'll write this now here. What should this function do? Print the binary representation. We think again about the return value and the parameters. So if we print something, then it's on the terminal. We don't need to return anything. So we don't need the return value. I need to write it up here. So void is the return value. Then we give it some meaningful name. I don't know, print binary representation. What are the parameters now? We want to print the binary representation of some input, of some integer, of some unsigned integer. So this an unsigned integer needs to be the parameter here. So unsigned integer I can call it number, I don't need to call it number. So this number and this number are not related. Let's call it something different. Have some better suggestions.
But then you need to replace it everywhere.
Okay, yeah, you are right.
Or you can limit.
You are right. Yeah, you are right. It's better to keep it this way. You will see because I'm lazy. Okay, again, we have the declaration. We copy it to the very bottom and write the function definition. And yeah, you were right. I just copy now the code that I have already written to this function because I don't want to rewrite it again.
Mm-hmm.
So we have this loop that prints the bits on 1 or 0. Yeah? And we have this unsigned integer number. This is now the parameter, and the parameter can be used in the function. So we can directly use here this the number in this function. Okay, now the question is just how to call this function. We said no return value, so we can just write print binary representation, and the only parameter is this number. So we give now this function the number, and the value of this parameter will be copied into this function below.
Mm-hmm.
Okay, and then our main function just consists of read integer, print binary representation. Okay. Check it again. So again, take the date of today, and it's the same output, and the binary representation is still printed. Okay.
So yes, this code will of course be published on the course website later. Then there was some suggestions about how we will be able to quit this program if we now loop this.
Mm-hmm.
But I think you'll come to this.
Yeah.
And then there was one question if for the assignment we shouldn't use unsigned int because there could be test cases with negative inputs, right?
Yeah, I think in the assignment you should use an integer, but here I just used unsigned integer that you can see it here as well.
I think this was everything.
And the last question here, do we have to put the function body below main or can it be above? It can also be above,
Mm-hmm.
but it's very nice if you can read through the main function at the very beginning. So if you open the file and you directly see the main function, and there is one more thing I want to add to the main function. Yeah, the main function is a bit like me. Yeah, I am lazy. I don't want to do anything on my own. I just want to say you should do this, you should do this, and you should do this. And this is the same as the main function. The main function does not want to do anything on its own, but it just wants to say, okay, please give me the integer. Okay, please print the binary representation of the integer. It's like your boss. Yeah, it just says what you should do, but it never does anything on its own.
Mm-hmm.
Yeah. Okay.
I see one more question, namely why doesn't this happen with the \n, so the return you enter at the end of the number that we saw last time?
Yeah, because with numbers this does not is not a problem because it's just skipped and we search for the next number.
Yeah, so scanf, if you write %d in scanf, then it automatically still skips these new lines and we don't need to worry about it. But if you want to read a string or a character, then these will get these new lines and all of those special characters and everything we type in, and then we need to worry about it. But right now we are only dealing with numbers, and then it just works. Yeah.
Okay, then we have this last to do here. Repeat the whole process. Okay, right? Now I do it very sloppy. I will just write while condition 1 should always happen, and
yes. So recall, if we have a Boolean expression, 1 is the value for true when stuff happens.
Yeah, so this will always happen. Now if I run it, I can enter a number and will be asked again. We can demonstrate this. always happens. Yeah, and now this was the question from before, right? Control C. So like if the usual copy command, Control C, you can see it here as well, terminates the currently running program. So we can get out of it. But of course, this is not very nice. So we should do something different here. We should maybe implement some stopping criterion. And yeah, maybe we can do this here now. I want to write a function now that asks the user whether we should repeat or stop the whole process. Parameters are again not needed because the function should return just the value, whether we should continue or not. So we have one return value here. I'll start writing the definition of the declaration of the function first. So maybe we return a Boolean value, should we repeat or not? And then we ask the user to repeat. No parameters, so in this case we write void here. And now we can, we assume that this function is already written, so we could say if we repeat, maybe, ask user to repeat, and if not repeat, then we just write break.
Yeah. Maybe this is also something you could remember. The break terminates this while loop here.
Yeah.
Yeah. I think you saw this in the lecture, but not yet in the practicals. So break breaks the more or less closest loop.
Yeah. Again, exactly. Yeah. So we go out of the while loop, and this is nice. Okay. The Boolean is not recognized. Why is that? Because the Boolean is not completely default C yet. So we need to include the library, and this is very easy to remember. Std bool.h. Yeah, and now.
Or it is, but not in the version we're using right now.
And now we can assume that the bool should.
Yeah.
Did I write it correctly?
Yes, but maybe you just. Yeah.
Okay.
Need to save it a few times and.
Yeah. Okay, now we have it. Now we can implement the ask user to repeat function. And I don't know, we do now the same thing as basically here in the read integer function. Just copy it and adapt it. So it's now a character is. Thank you. Character is the input. We can initialize it with 0.
Maybe do you want to continue or something?
Should we repeat? Or continue is much better. Continue. I have some mess here. Large mess. Okay, continue. Maybe yes, no. And then we need a character, read the character, we store it in the input, we return it, not directly, because we say if the input equals yes.
Why?
Yeah, we return true. If the input equals, let's say in all other cases we return false. So only if the yes is entered, then we really return true here, that we repeat it. And in all other cases, we say it's false, because what if the user enters something, an A, for example, then we don't want to do this here.
So do we now need the getChar after the scanf?
Yeah, let's try it out. I think it's completed, right? Yeah.
Now the main is really nice to read.
Yeah, so this is more or less clear. So enter positive integer 42. Yeah, and yeah, exactly. Now we have the problem that we did not get asked for continuing because we need this input buffer clearing thing that we have seen last time.
Yes.
Because
now we are reading characters, and every time we read these characters, we need to worry about this stuff.
Yeah. So basically, the cleanest way would be that we do it after this scanf. clear input buffer. And we also do it after the scanf here below. Yeah, in the ask user to repeat function as well as in the input integer function. Okay, so we need to do this twice. So we have to do it multiple times in the same program. Why should we not create a function for that? Yeah, so we can create a function clear input. And we just call this function here. It does not need to take parameters. It does not have a return value. We just clear the input buffer here. And we do the same thing also here. Clear input. Okay, now what is the what do we need here? No return value, clear input, no parameters. Copy it to the very bottom again. And if I remember correctly from last time, we called why we got the characters as long as there are not \n. And
yes.
we did this repeatedly. Okay.
Yeah.
Without the body of the while loop.
Yeah, if you do a semicolon after while, then the body is just empty.
Yeah.
Yeah.
Okay, now we called this function at this location here and at this location. And this is a use case of functions, that you can reuse the same code at different parts of the program.
Mm-hmm. So just a few questions.
Yeah, perfect.
Mainly, one question was, is it okay to use functions within a functions, or should we return to the main and then call the function? No, as we just did, we are here calling this clear input function from the read integer function, which was called from the main function. So of course it's possible to nest these functions as much as you want, as long as it's still readable.
Yeah.
And yeah, of course you should, and you also should do this calling other functions in functions.
Yeah, maybe not in the assignment one, but later on you will do this. You will have like 10 functions that you call.
Is, according to the style guide, a while loop in the main okay? Yes, it just shouldn't be too long.
Yeah.
Then also, is it okay if my function returns 0 or 1 instead of a bool? And then you check which it is. And this is of course okay, because the boolean is just 0 or not 0.
Mm-hmm.
And then is it considered a mistake if in the scanf they just put the space in front of the person C instead of doing this input clearing thing?
Yeah, if it works, it works.
Yeah.
So yeah, basically with this scanf you will not work in the future assignments, because you cannot do a proper input checking there. But for assignment 1 this is well enough.
So you can use most functions you find in the standard library. Yeah, I think we have a link to that.
Yeah.
In the coding style and guidelines. Okay, then do you want to try it out?
Yeah, but let's try it. So now enter positive integer, maybe take 42 again. Continue. Now we say yes, because only the little y continues the program. We can enter another positive integer. Yeah, today's date, for example. And now if you type no or something else, doesn't matter, we would leave the program. So this really does what it should do. Yeah. And again, really the important thing is main function should be very, very small. Yeah. Maybe, do we have time that I do a little fix in the main function?
Yeah, sure.
Because I think this is ugly, this break here. So maybe we can different bool repeat is true, so that it really enters the while loop, and then we just set the bool here and we get rid of the break, and it's much cleaner now. Yeah. Thank you.
Yeah. And yeah.
Now I don't think we need to try it again. It should be clear. So this is cleaner than a break in this case.
Okay, then I think let's just answer some questions from the chat.
Yeah, but can we go to the summary first? Because now we concluded this example here. Yeah, again the code is on the Notion then. Today we saw the introduction to Valgrind. We talked more about structs and a lot about functions, more theoretically in the first place, and now with more practical thing. And just remember, next time we'll meet each other in the lecture hall and
In
not
person.
in person, not on YouTube.
Yes.
And now we continue to the
Yeah.
questions.
I think I just saw one. Can we use arrays in our assignment 1? And this is a general question. Can you use something in assignment which we haven't covered in this course yet? And the answer is yes, as long as it follows our style guides. So it's also from the standard library. And at the assignment interview, you will probably, or you will need to explain what you used. So if you use arrays now in assignment 1, you will need to be able to answer questions about and how you use those arrays at the assignment interview. And you will also always need to make sure to not introduce any memory errors.
Yeah. Any further questions? Now it's your chance.
Yeah, because I think David will agree we still have a lot of time.
Yeah.
So one question is, how would you compare structs?
Yeah.
So if you think about our point example, if you have 2 points which have the values 1 for x and 2 for y, and I have 2 of those, so point 1 and point 2, how would I compare those? So here, if I have this point 1 and point 2, how would you compare those? Well, you would probably need write an extra function which you call like do or equal points or points equal or something, and then you in this function you need to compare the x and the y of those points. So basically point 1 dot x. How do I close this?
Wrong keyboard
Yeah.
layout again.
Equals point 2 dot x, no, equals, and the same for y. So if you want to compare points, you need to do something like this.
Yeah, the question, follow-up question, is it possible to directly compare the structs?
Something like this.
To directly compare these objects?
I'm not quite sure what would happen. I think it could work.
So not directly. I don't think that you can write it directly in the code. But
Point one equals point 2.
I don't think that this works.
Like this?
Yeah.
No, not safe.
Can you run it directly here?
Yes.
Yeah.
But we need to print it somehow.
Yeah, it's quite the question whether we get a compilation error or not.
Let's see what happens. Okay, it doesn't work. We get an error. Yeah. Invalid operand. So no, it doesn't work.
So really have to go through the members. There are functions that check the memory, so that compare the memory behind the objects, but this is a bit more advanced now.
I have submitted all A1 weeklies almost a week ago, but I have received grades for them. It says NA. Did I do something wrong?
No,
Okay.
you will not receive your grade in online GDP for the exercises. So you will receive your grade and during the assignment interviews you will see. And you can complain there if something is not correct.
Okay, this about struct comparison, which we just saw, is impossible because you get this error. Is it possible that the assignment passes all public test cases and fails some private test cases? Yes. This is possible, and then you should really try and go through the assignment again, see if you implemented everything, and also double checks if everything you print is exactly the same as in the assignment.
But you can see the output of not the output, but you can see the result of the private test cases. If you test it online on GitLab, you don't see the output, but you see the result, whether it's passed or not. Okay. I think we don't want to stop with an error message on the screen. Now we have something better for that. Can stop the stream. Yeah. Yeah, I think that's it. I hope you are now really prepared for assignment 1. So today's practice were really relevant for A1.
And I think today's lecture will get even spookier.
Yeah, it's really spooky. So please stay here at our YouTube channel and watch today's lectures.
And don't get scared. Okay.
Then have all the best for assignment 1, for the last week of assignment 1. Have a nice weekend, or have a nice extended weekend.
Yeah, and we'll see us next time.
In lecture hall P1.
Yes.
Bye.